Okay, hello. I hope that last worksheet wasn't very difficult. That was about as far as 7th grade math asked you to go with linear equations in one variable. I do hope that if there are any questions or any comments, I hope that you would comment directly into the YouTube video link. There should be a place to put comments. I would love to know at the end of each video sort of your thoughts, whether this assignment was very easy, you're ready to move on, or this was very challenging, we may need another day on this. But the comments there on the YouTube link should be a good place for us to leave some feedback until we get more live with our interactions. And always remember to email me with any questions that you have, any comments that you have on the lesson. But here, we've got a new twist that's been given to us here. Our last problem, our variables were all on the left. It was a very easy two-step equation. And here we have something new. We have x is our variable, and we're still wanting the same thing. We're still wanting at the very end x equals something. We're wanting x equals a constant. We're wanting to get x all by itself, or to isolate that variable. But here we have negative 2x on the left-hand side of the equal sign, and we have negative 5x on the right-hand side of the equal sign. What are we going to do here? We've got variables on both sides. Before we can take this to a two-step equation, we have got to get our variable on only one side of the equation, because that's what we want our finished product to look like. We want to have x all by itself. Now, I'd encourage you to pause the video here for just a moment and see what you think you can do here. Okay, if we might have an idea that we can move this to one side or another. You remember on coefficients only come in and out of equations by multiplication and division. So you might be thinking, well, we need to divide everything by negative 2 or divide everything by negative 5. Okay, we could do that. That's legal, but here we're not necessarily trying to remove a coefficient from a variable yet. We're trying to move that whole term, the coefficient and the variable together. We're trying to move that term to either the left-hand side or the right-hand side. Now here, you've got two roads here you could go down. I prefer to think about this like a tug of war. I prefer to think about this as, okay, I've got negative 2x and negative 5x right here. I'd like to think about, okay, which number is greater in value, negative 2 or negative 5? We would know that on a number line, negative 5 would be far to the left, negative 2 would be closer to 0, so we know that negative 2 is the larger of the two expressions. And so what I'm going to do is I want to let this negative 2, which is bigger, win the tug of war. It's going to pull this negative 5 over here to the left. So I want to remove a negative 5x from the right-hand side of the equation. How I can do that is I can think about, okay, negative 5x has been brought into this side of the equation. What if I added 5x to this side of the equation? If I have negative 5x and I add 5x, well, that would just be 0. That would leave me with nothing but a positive 28 on the right-hand side of this equation. And so now my variable is gone from the right. But again, the first commandment of algebra is anything I do to this side of the equation, I must do the exact same thing to this side, or my equation will not stay balanced. So I'm going to add 5x to this side. Add 5x to this side. So I've got negative 2x plus 5x. If I evaluate that, that leaves me with 3x here. Well, and then we have this negative 44 that is sitting out front. We'll bring him down and let him play. Since this is a positive 3x, this will be a plus. Now, that equation ought to look much simpler. All we've done is one step. We've moved the variable from being on both sides of the equal sign to where now it's just on the left-hand side. Now I can think about what are my last two steps to solve this equation. Well, there is a constant that's over here with my coefficient. There's a constant right here. I'm going to add 44 to this side because that is the opposite of negative 44. That will cancel that out, making that 0 and leave me with 3x on the left. If I add 44 to this side, 44 to that side, that's going to be 8 plus 4 is 2. Carry the 1. 4, that's going to be 72. Okay, that's going to be 72. And so now I have a variable on the left attached to a coefficient and a constant on the right. This is looking more and more like my finished product each step that we take. Now, I'm going to take this side and divide it by 3 because coefficients come in and out of equations by multiplication and division. And since this 3 became attached, sorry, I got to watch my shadow there with my hand. I'll learn how to do this eventually. Since this 3 became attached to the x through multiplication, it's going to leave by division. And so if we divide both, or if we divide this side right here by 3, that leaves us with our variable x all by itself. Now, if we do this to this side as well, 72 divided by 3, I have to mentally think about what that is. I have to think about, okay, 60 divided by 3 would be 20, and this is 12 more, so that would be 4 more, so x would equal 24. X would equal 24. Now again, that's just 3 steps. The sheet that we did earlier today had only 2 steps for the equation, but this one right here has 3. Our step number 1 was to get variables on only one side, moving the variable from the right side, eliminating that variable here, bringing it over here, and then our step number 2 was to remove the constant, and then our step number 3 is to remove the coefficient. And after that, we really have step 4, which is to see, is our solution going to keep this equation true? Is our solution going to keep this equation true? And I'd love for you to pause the video right here and see if we're right. Pause the video here, see if you can plug 24 back in for x, and see if it keeps the equation true. All right, let's see if we got it. It's going to be negative 44 minus 2, and right there I'm going to plug in my solution. Plug that in there for x. Let's continue writing this. We've got negative 5, and we've got 24 plus 28. Oh, I didn't stay consistent there, did I? Well, if you expect consistency, you're going to have to pay a little extra. Let's call that 28 right there. All right, so let's think about this. We've got negative 2 times 24. I think I can do that math in my head. Negative 2 times 24, bring my negative 44 down here. Negative 2 times 24 is going to be 48. Negative 48. Here we're going to have, let's see, negative 5 times 20 would be negative 100, but this is negative 5 times 24, which is 4 more, so 4 times negative 5 would be another negative 20, so this is going to be negative 120 plus 28. All right, on the left-hand side, we've got negative 44 minus 48. I know that's going to be a negative. Let's see, subtracting those two, that's going to be 92. If I ever do something wrong in my arithmetic, please just don't laugh. I'll try to catch it eventually. Let's see here, 120 minus 28, that is also going to be negative 92. And let's go back to the green, having a Christmas theme here today. Negative 92 is equal to negative 92, so we know that our solution does work. We know that x equals 24 is a valid solution for this problem. And I would highly recommend you get in the habit of plugging your answer in and verifying that it keeps your equation true. Because if you do that, you're absolutely certain that 24 is a solution to that answer. You can move on to the next problem confident that you've got it right. And that's a very nice thing to have. Okay. Take a shot at the 9 more problems on this sheet, and we'll wrap this up here in just 1 second. Thanks.